Hello, my name is Jackson Sternberger. Today I will be doing a root cause analysis over the Kansas City Hyatt Regency Skywalk accident. On July 17, 1981, two suspended skywalks inside of the hotel collapsed into the crowded atrium. This accident killed 114 people and over 200 were injured during the process. This led to the deadliest accidental structural failure in United States history. The design had been modified from the original plan during fabrication, which doubled the load upon the upper walkways connections. Investigations revealed engineering negligence, miscommunication, and lack of process control during the process. The walkways were hung from the ceiling by long steel rods called hanger rods. In the original design, there was supposed to be one continuous rod that ran from the ceiling to the walkways, so each carried their own weight directly to the ceiling, which this is called a proper load path. But the box beam connections were designed only to hold one walkway load each. If this were to be built correctly, the system would have met code and safely supported the full occupancy. This slide is going over the design change and structural breakdown of the project. For the project, the fabricators of steel was Haven Steel Company. They were the subcontractors, and they requested that for easier assembly that two shorter rods be used instead of one continuous rod. The engineer of record verbally approved this, but he did no recalculations or documentation. This created a huge issue because when there was no recalculations, this did not take into account for the alteration doubled the load on the walkway's upper connection. So if they're doubling the load, this is where our hazard comes in of not being able to handle what's being built and what's going to be eventually walked on and the load of people walking. The box beam welds and plates that were used were too thin for this project to resist the added stress. What was initially supposed to be used was going to be able to hold it, but when they doubled the load, these welds and plates were no longer able to withstand the pressure. And eventually, when people crowded the walkways and walked all over it and added weight and stress, the welds tore, causing both walkways to fall in seconds. The change was in order to save costs and simplify the design process, which ultimately led to their fail because the engineer of record did not recalculate and had no documentation. Instead of a single hanger rod, multiple were used, which increased the force on the support beams. Ultimately, a lack of communication and a drive to save money led to the collapse of this walkway. So this slide, I'm going to be going over why the collapse happened, and I'm going to be using my example from my root cause analysis for my information. The engineering of record approved a critical design verbally without performing recalculations or issuing drawings. There was a poor communication, lack of accountability, and failure to report visible warning signs throughout the whole process and all involved. For machine, the welding and fabrication tools produced weak and inconsistent joints that were not able to hold this doubled load. This also goes back to man as well, but what they used was not adequate for what they did because they didn't properly check. For materials, the box beam weld plates and welds were too thin to withstand the doubled load from the hanger rods. These were inadequate because they weren't able to handle that doubled load, and this is what caused, once they were stressed, to collapse. For the method, there was no formal process for reviewing documents or design changes. This comes from allowing verbal approvals instead of getting documentation, recalculating, doing everything the correct way, but rather they wanted to save time and hit deadlines instead of just going through the correct process. There was no proper engineering procedures in place, and the quality control and inspection system failed to detect or question the unsafe, which allowed for disaster. For the environment, the scheduling and prioritizing of trying to hit deadlines caused for them to overlook the monotonous and mundane things, such as just simply not verbally approving something, but getting the documentation, checking it, making sure your P's and Q's are straight. Instead of doing that, they wanted to hit their deadlines. The culture of this workplace encouraged informal decisions. The engineer of record lacked engineering ethics and had poor coordination among his teams. He had no control over the situation. He was just trying to get through it, get it done, get it pushed out, instead of doing things the right way. And this caused deaths. This caused the deadliest structural failure in United States history. For measurement, there was no recalculation, there was no load testing or code verification that occurred after the design change. How they overlooked this, I don't know. It was so simple that they could have just went through it. They could have got the proper documentation. They could have got the proper drawings. They could have got the proper materials and proper machines to build the right things. But no, they chose to rather overlook that and just go off the word of mouth and skip through all these things. Visual inspections were treated as sufficient, which allowed critical design flaws to go unnoticed until the collapse. And these all ultimately led to the collapse of the skywalk. For this slide, I'm going to go over the lessons that we learned and preventative actions. The Hyatt collapse happened because safety checks were ignored, there wasn't proper documentation, and communication broke down on a massive level. Every design change now must go through full review process, written approval, proper calculations, and peer verification, which means that everybody involved knows what's going on and it's been verified. Modern codes now require load testing, design audits, stronger Q&A procedures, question and answer procedures because of this event right here. But the rules only work if people follow them. This was just as much a cultural failure as it was an engineering one. Engineers today study this exact disaster as a reminder of the convenience, cost, and speed should never outweigh safety. And in conclusion, this tragedy right here shows us exactly why safety isn't about just avoiding mistakes. It's about building a system that is strong enough to catch them before they cost lives. If the team had taken just one more day to thoroughly go over their plans, their documents, make sure everything's right, all their P's and Q's are in order, they could have saved 114 lives and many, many injuries. And they could have avoided the deadliest structural failure in United States history. Thank you.